Hello and welcome back. In this video I am going to teach you how to solve this math problem which can be found on page 32 number 12 in your book. Now, we have here a problem that is more on the concepts. So the question is, if f is non-trivial, are all terms of the linear equation 1 of section 1.2 of the same degree of homogeneity in y and its first n derivatives? Explain. So I have already written here for you the said equation. So we have here the general form of the linear equation here, and we are going to find out if both this has the same degree of homogeneity, if f of x here is non-trivial. So let's find out. First, in order to find out, we need to use the test for homogeneity. Now, as you may know or may not know, the test for homogeneity demands that we substitute y. We turn y into delta y. So how this system works is that when we have substituted y for delta y and then factor out the lambda y. So if we have already factored out lambda y from that said equation, then the exponent of that lambda would be the degree of its homogeneity. So now let's do it. Let's substitute it. So we replace y by lambda y. So we have a sub of x lambda y. Perfect. By the way, this n is the derivative. Okay, if it's n, then it's maybe second, third, fourth, fifth derivative, or what have you. And then this is added by a sub 1 of x lambda y is of n minus 1 plus plus a n minus 1 of x lambda y prime plus a of n lambda y. There. Then this is equal to sub of x lambda y bar of n a sub 1 of x lambda y n minus 1 plus plus a n minus 1 of x lambda y prime plus a of n lambda y. So now, as you have noticed, I just factored out lambda. So why is that? Well, I just did this, really, and so basically that. So what I did is, for example, we have a second order derivative here. So if we so this is just lambda y double prime. So just that's lambda y double prime. Then this is equal to the derivative of lambda times the derivative of y. that's because lambda here is basically just a constant, and when we derive things we usually get the constant out. So there you have it. And then after that we just factored out lambda. So that's what's going on here. So let's proceed. Now this is equal to lambda times the quantity of a sub o x 1 which power of n plus this becomes a n minus 1 of x y prime plus a of n y. Looks familiar? Of course it is, because it's just the original. See? Let me show. It's just the original. Okay. Original. There we go. It's just the same as the original. So emphasize this, that this is the original. Which is this is equal to f of x. So this basically just becomes lambda times f of x. So it just has the same degree of homogeneity. It's as a 1 degree of homogeneity. Degree of homogeneity is 1. So just the same throughout the terms. Now when can this be true? This can only be true if f of x is not equal to 0. Because if f of x is equal to 0, then in lambda raised to the power of k, f of x in k would be anything really. Would be anything really, because no matter what I input to that exponent of lambda there, it will just become 0, because f of x is 0. If you multiply lambda raised to the power of k to 0, then it will be 0. So no matter what I put there, it's still 0. So it still holds. But if f of x is not equal to 0, then this holds. So this, if f of x is not equal to 0. So this thing holds. So that's the answer. So let me just put this in a much more larger text. The degree of homogeneity is the same. That's the answer.